Hello everyone, this is James Shore with another how-to video. I'm recording this on October 2nd, 2015. In this chapter, we're looking at test-driven development, and in the last episode, we introduced the fundamentals of test-driven development. We talked about the red-green refactor cycle and talked about how important it was to work in small steps and take advantage of that hidden first step, which is think about what you want to build and how you're going to write a test that will get you there, and doing that in very small steps. Now, in this episode, I want to start talking about front-end code because all the examples we've given up until now have all been based on just sort of fundamental JavaScript arithmetic and don't really vary across browsers or don't really need a browser at all. But our application, what we're going to be building in this series, is this simple tab switching effect where we can switch from one tab to another. This, of course, is entirely done in the front end. And how you test it is a little bit more complicated. Actually, it can be a lot more complicated than just doing normal, simple tests of arithmetic. And actually, this is the kind of thing that makes test-driven development take a lifetime to master. It's really easy to learn the basics of doing red-green refactor, and it's actually pretty easy to learn how to do it with simple algorithms and arithmetic. The challenge comes in when you have to start working with the outside world, things like the web browser and its associated DOM. So in this episode, we're going to look at what the DOM is, what is the document object model, and how can you manipulate it from JavaScript so that we can test it using test-driven development. Well, the short answer to that is that the DOM is the browser's internal representation of a web page and an API, a programming interface, for accessing that representation from JavaScript. In order to really explore this, we're going to need a simple web page. And let's go ahead and mock up our tab application. So what I'm going to do is create a web page that has everything that we need in order to do our tab application. So let's take our hello world and get rid of this script here. We're going to just sort of start out. We're going to need a title, which I'll call tab example. And we're going to want a list of tabs across the top. So let's make that an unordered list. And let's give it a class so we can style it. If you're not familiar with HTML and CSS, I apologize, but we're not going to go into how HTML and CSS works in this video. So I recommend that you find one of the many excellent courses online for HTML and CSS and check those out. Or you can just follow along and pick up the basics as we go. We're not going to delve into many sophisticated aspects of HTML and CSS in this series. Anyway, so we're going to have a list of tabs. Let's go ahead and toss a couple of tabs in there. Each one will be a list item, and we'll make each one a link like this. We're not going to be too fancy about it. And we're also going to need some content for these tabs. So let's make a container and then some content divs. And in those content divs, we'll just put some random stuff. So this will be tab 1 content as a header, and then random junk, which I already have set up, and so I'll just paste in here. Then after that first tab, we'll do another tab, and I'll just go ahead and paste in the rest of it. So there we go, a list of tabs and then content for those 3 tabs. Now if we run this and look at it, it's going to look very different than our final product because we don't have the JavaScript yet to make it switch back and forth. So we see all the tabs together. It's also not styled very nicely. So I'm going to go ahead and make a style sheet and put that in as well. I'm going to call it screen.css. And I'm just going to copy in something that I've already pre-prepared. If you'd like to get this CSS, you can click the source code link below this video on the Let's Code JavaScript site and look for screen.css in the source/content directory on GitHub and download it from there. Or, of course, you can write your own. Now, I don't have this linked in yet, so let's go ahead and link in the CSS. All right, with that linked in, we should now be able to serve and see our style in place. And there we go. Now, what we want this to be able to do is to change when we click, and that is what we're going to be developing. But first, let's see how the DOM plays out. So here's our HTML. We've got our header, and then we've got our body and the unordered list with the tabs as list items and as hrefs, and then a div, which is the container, and then one div for each of the contents. In fact, let's take these IDs out. We don't need those right now. It's just from what I pasted in before. So each div has one of the tab's contents in it. This gets parsed by the browser and turned into a data structure in memory that you can access via the DOM. And if you go into Firefox or another browser and you bring up the developer tools and you look at the inspector, you can see that DOM in the browser. So this is not the actual HTML directly. This is the representation of what you can get via the DOM. It looks like pretty much the same thing. We've got our header, we've got the body, we've got our UL tag with all the tabs in it. We can expand that. We can see what's inside of each of these tabs, the anchor tag for the link, and so forth. And there's our container and our other containers. And I've taken those IDs out, so if I reloaded it like this, we should see those disappear. Yeah, this was just from before I made that change. So you can see each element in the document shows up in our DOM. Each of these lines is called a node or an element. An element is a type of node, technically. And each of these elements can be accessed from JavaScript, and it can be changed in JavaScript. We can add elements, we can remove elements, we can set the HTML and attributes of an element. There are all kinds of things we can do. And that, of course, is necessary for us to test drive this. Now, we could spin up a server and load a page that was served by that server and then have access to the HTML, but that wouldn't be a good unit test. A good unit test, which is the majority of the types of tests you want to write, is focused on just the minimum necessary to prove whatever point you're making. Just like with our addition test, in this test where we're testing that we add positive numbers, we only look at 3 plus 4 equals 7. In this one where we're testing floating point, we only look at 0.1 plus 0.2 equals 0.3 and a little more. Subtraction, very similar. When we're testing our JavaScript that manipulates the DOM, we're only going to want to test that little part of the JavaScript, which means that our test needs to be able to create the DOM that our production code is going to manipulate. If that doesn't make sense now, don't worry about it. It will make more sense the further along we go. What you need to know for now is that we can, through our JavaScript program, add elements to the DOM. We can remove elements from the DOM. We can see what's in the DOM, and we can change what's in the DOM. And that is going to be very important for us to do testing. So let's see this play out in practice. Because we are now starting to work on our actual tab application, let's get rid of all of this old temporary code. We'll get rid of addition. We'll cut out everything that's in our app. We'll cut out most of our tests that are an addition test, just bring it down to the bare bones. And we'll take out all of our to-dos. And let's go ahead and try that. That should still pass its test. We do have one test in there that doesn't do anything, and it should still run as well. And it looks like it does. Great. So I'm going to check this in. Set up a bare bones tab example. So you'll go ahead and close these other things down. We don't need them right now. So in our test, we're going to need to be able to manipulate the DOM so that we can test the way our JavaScript works in the DOM. And there's three main things that we're going to need to understand. We need to be able to add elements, we need to be able to modify those elements and configure them, and we need to be able to remove elements. The first of these is just adding an element. What you can do with the DOM, and this is a feature of every browser, but it's not always supported consistently across browsers, and that's why we do all this cross-browser testing. But what you can do in every browser is say document.createElement and pass in the name of a tag. This will create a node, an element, with this name. It's like putting a div in your HTML. With one exception, it's not actually in the document. You can create the element without it being part of the document yet. Then, once you have it as part of the document, you can manipulate it. We can say things like div dot, and you see here in WebStorm, it brings up automatically all the stuff that I can do. You can say div.innerHTML equals something. So we can have this div contain some text. This is an example, for example. And once we've configured the element, we can add it to our document. We can add it to another element by using the append child method. We can say some element dot append child div, and that will put our div inside the something element, whatever that may be, at the end. And there are a few elements that are always available to you as globals. One of them is document.body, and this is, unsurprisingly, the body tag. So if I've done this correctly, and there's no guarantee that I have, at the end of this test, our document should contain a div, our document body should contain a div with "this is an example" inside of it. So let's run it. Well, it says it passes. So that means at least we didn't type anything that was an egregious syntax error. But we can't actually see this because when we do Jake run, this code is not running. This is our test. It doesn't run in our application. So what we need to do instead is see this in the debugger. Here's how you do that. If you go over to your Karma, and you can do this again in any browser, and you click the debug link, and I often hold down Command or Control on Windows to open it in a new tab, you'll see the Karma debug runner. The debug runner basically runs Karma in its own window without all this Karma stuff. So normally the way Karma works is there's a frame in here that runs your tests. This is just the contents of the frame. And also normally when Karma is done, it erases that frame, but here it leaves the frame around so we can see what's inside of it. And if I open up our inspector, which again is Tools, Web Developer, Inspector on Firefox, or as I just did, Command Option C or Control Shift C on Windows, I believe, we should be able to see what we've got in here. And we got a bunch of stuff that Karma has provided. And then, bam, div. This is an example. There's our div. That's how we know it's working. And we could put something else inside that. We could put a paragraph inside of it, for example, by saying, well, take a moment to see if you can figure it out for yourself. What 3 lines of code would you need to write in order to put a paragraph inside of that example div? Pause the video and give it a try. Okay, here's how I'm going to do it. I'm going to say document.createElement with the P to make a P tag. Then I'm going to say p.innerHTML equals, well, in this case, I want the body, what's inside the P tag to be, this is an embedded paragraph. And then I need to append that to the div. That will put it inside the div. So I say div.appendChild P. And then if I run the test, because that will load the new code into Karma, and then reload this debugger, we should see a div with a paragraph inside of it. Oh, but you know what? It didn't show up with our inner HTML, and that's because I always do this. I spelled it wrong. It needs to be capital HTML, not lowercase TML. So let me run that again. Reload it again. And there we go. There it is. So that's adding and manipulating elements. We create the element here, we manipulate it with inner HTML, and there's similar things you can do with attributes, and we append it to the document here. Now, if you want documentation on how this works, the best resource I know of is MDN, the Mozilla Developer Network. Just say MDN when you're doing a search, do MDN and then whatever you want. In our case, let's say create element, and it will pop up with just fantastic documentation. So you can see everything that's in here. Now the DOM is big and complex, and sometimes it can be a little hard to find your way around, but just click around, become comfortable with it, and you will start to get used to it. When there's incompatibilities across browser, MDN will often describe that as well, although create element is really fundamental and is supported consistently in all browsers, as far as I know. Fingers crossed. All right. Now, the next thing we need to do, in addition to creating and manipulating elements, we also need to delete elements. So after we create these elements, let's go ahead and delete one of them. Let's delete the div. The way you do that is with div.remove. Well, sort of. Let's go ahead and give this a try. I'm going to run our tests. And you'll see that it worked on mobile Safari, it worked on Firefox, it worked on Safari, it worked on Chrome Mobile, it worked on Chrome, but it did not work on IE9 or IE11, and that's because remove is a newer method on the DOM that isn't supported by any version of IE except for IE Edge. And that is the real censored word here of working in JavaScript. JavaScript is actually a great language, but working with the DOM, different browsers support different parts of the DOM, and that's why we do our cross-browser testing. So rather than using remove, because that is not supported consistently, what we need to do is get the parent element, or the parent node as it's called, and ask it to remove a child, which is the div. That's how you consistently remove elements across browsers. If we run that, we'll see that it passes, there's no errors. And if we actually go in and look, we should see that the div disappears when we reload. And there it is, it's gone. So that's a brief introduction to the DOM. 3 things that are going to be really important for you to know as we're doing test-driven development of client-side and front-end JavaScript: creating elements, modifying them, adding them to the DOM, and removing them from the DOM. There's lots more that you can do. Go ahead and check out MDN if you like and learn all about it. Next time, we're going to put this all together. We're going to take our test-driven development red-green refactor cycle, and we're going to take our knowledge about the DOM, we're going to put them together to test drive our very first bit of front-end DOM manipulation code. I'm looking forward to it. Your exercise for this time is to go ahead and experiment with creating and deleting elements. You can just do it in your test. Use the debugger to see what's coming out. If you're feeling more ambitious, poke around in MDN and see what else you can find. One challenge I have for you is to add and remove attributes from an element, and try adding and removing classes as well. Another challenge for you is I've shown you how to use the debugger to inspect the DOM in Firefox. Go and try a few other browsers as well and see if you can figure that out. And then finally, if you're feeling very ambitious, try to take what we've done so far and test drive the beginning of the tabs example. Remember, what you do first is think about what bit of code you want to write first and make it small. So what small thing can you write that starts us down the path of working on our tab-based project? What's something really small you can do? Test drive that. Next time, that is exactly what we're going to do. Thanks for watching, and I will see you next time.